This video is on section 2.6, which talks about finding rational zeros of a function or a polynomial function. This theorem that's on your screen here is the rational zero theorem. It basically looks all crazy and weird, but what it says is if you have a polynomial, a function that has all integer coefficients, then every rational zero will have the following form. It will be a factor of the constant term divided by a factor of the coefficient. So what you can use this theorem for is you can look at a polynomial and figure out what all the possible rational zeros would be. And a zero is basically if you were to set this function equal to 0, I'm going to do it like this. Okay, what would x equal if that whole entire function equaled 0? We did this quite a bit with quadratics. We would factor it and figure out what our zeros were. So to do this, it's actually pretty easy. What you have to do is you have to look at the constant. The constant is right here, -18, and you're going to list out all of its factors. So I'm going to do that in red, and I've got plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 6, plus or minus 9, and plus or minus 18. So those are all, it's a 3 right there, all of the possible factors of 18. Now in another color, I will use green, I guess. I will list all the possible factors of my lead coefficient, which luckily there's only 2 of those, plus or minus 1, plus or minus 2. So if I just put all of my different combinations of a ratio between a factor of the constant divided by a factor of the lead coefficient, I will have all my possible rational zeros. So I'm going to do that in black. So basically, I'm just going to list them over here. So I'm going to take all of my factors of 18 and put them over each of these factors. So it's plus or minus 1 over 1, plus or minus 1 over 2. Okay, then I've got plus or minus 2 over 1, plus or minus 2 over 2, plus or minus, 3 over 1, come down here, plus or minus 3 over 2, plus or minus, keep going here, 6 over 1, plus or minus 6 over 2, plus or minus 9 over 1, plus or minus 9 over 2. Oops, sorry about that. 9 over 2, almost done. Plus or minus 18 over 1. Plus or minus 18 over 2. Now, if you were to simplify all of these, you would have some duplicates. So the list really isn't as big as it looks. So I'm going to go over here and pick a list over here in blue to the left here. So this is 1, plus or minus 1. And I'm going to put a plus or minus here. Sorry, this is not being very nice to me here. Plus or minus up top, and then just list them down instead of rewriting plus or minus every single time. So this is basically 1. This is 1/2. This is 2. This is 1, which I already have in my list. And then this is 3. This is 3/2. This is 6. And this is also 3, which I already have in my list. This is 9. And this is 9/2. I'm going to come right here because I'm running out of space. And this is 18, and then 18/2, which is 9. So I already have those. So 1, 2, 3, 4, 5, 6, 7, 9 possible rational zeros for this polynomial. Actually, let's double that. We got plus or minus, so it would be 18 possible rational zeros. And that's how you would list all the possible rational zeros. If there are rational zeros to this polynomial, it is definitely going to be in this list of numbers right here. And that's basically what the rational zero theorem says.